Isotopes are distinct forms of the same chemical element that differ in the number of neutrons within their atomic nuclei. While each element is defined by its number of protons, known as the atomic number, isotopes of an element share the same atomic number but have different mass numbers due to variations in their neutron count. For instance, carbon-12 and carbon-14 are both isotopes of carbon, with the former having 6 neutrons and the latter 8. Despite having the same number of protons and thus the same chemical properties, these isotopes exhibit different physical properties, particularly in terms of stability, which can lead to the phenomenon of nuclear radiation. Nuclear radiation occurs when unstable isotopes, also known as radioactive isotopes or radioisotopes, undergo radioactive decay to achieve a more stable state. This process involves the emission of particles and energy from the nucleus, and it can occur in several forms: alpha particles, beta particles, and gamma rays. Alpha particles are a type of nuclear radiation composed of 2 protons and 2 neutrons, making them essentially identical to the nucleus of a helium atom. This gives alpha particles a relatively large mass and a +2 charge. Due to their mass and charge, alpha particles have low penetration power, meaning they can be stopped by a sheet of paper or even human skin. However, if alpha particles are ingested or inhaled, they can cause significant biological damage because of their high ionization potential. Beta particles, on the other hand, are high-speed electrons, or in some cases, positrons, that are emitted from the nucleus during beta decay. In this process, a neutron in the nucleus is transformed into a proton and an electron, with the electron, beta particle, being ejected from the nucleus. Beta particles are much lighter and faster than alpha particles, and they carry a single negative charge. While beta particles can penetrate further than alpha particles, they are still less penetrating than gamma rays and can typically be stopped by materials like plastic or a few millimeters of aluminium. Gamma rays represent another form of nuclear radiation but differ fundamentally from alpha and beta particles as they are not particles but rather electromagnetic waves. These waves have very short wavelengths and, consequently, very high energy. Gamma rays are often emitted alongside alpha or beta particles during radioactive decay as the nucleus releases excess energy. Due to their lack of mass and charge, gamma rays are highly penetrating and require dense materials such as lead or several centimeters of concrete to be effectively shielded. Unlike alpha and beta radiation, gamma radiation can pass through most materials, making it particularly hazardous as it can penetrate the body and damage internal organs and tissues. In summary, isotopes are variants of the same element with differing neutron counts, leading to different nuclear behaviors. When these isotopes are unstable, they may emit nuclear radiation in the form of alpha particles, helium nuclei, beta particles, high-speed electrons, or gamma rays, short-wavelength electromagnetic waves, each with distinct properties and levels of penetration.